bracket is about the variation of parameter. Okay, and the example that I'm gonna use today is y double prime minus 2y prime minus 3y equals negative 3x e to the negative x. Okay, and this example, it can be done using the what do you call the undetermined coefficient. As you see the gx here as the algebraic function or the polynomial function, okay, polynomial, and also the exponential, which is a product of those two types. So it can be done two different ways, but both ways you're gonna have to find the solution yc or the complementary solution from the associated homogeneous equation y double prime minus 2y prime minus 3y equals 0, and the auxiliary equation exactly the same way, m squared minus 2m minus 3 equals 0, factor completely. Okay, so gonna be minus 3 here and then plus 1 here, right, equals 0. So far so good. I'm sure you guys are very comfortable with the homogeneous equation solution. And then we get m equals 3, m equals negative 1. That tells you y1 is e to the 3x, y2 equals e to the negative x. The order doesn't matter. Okay, if you starting with this way, you're gonna have to keep going with y1 as e to the 3x, y2 as e to the negative x. Number three now. We're gonna make sure that the equation is in the standard form. Okay, from the equation which is already in the standard form, like y double prime minus 2y prime minus 3y equals negative 3x e to the negative x. Yes, because the leading coefficient here, or the coefficient of the highest order is 1. Okay, this is negative x. Okay, that means our f of x is negative 3x e to the negative x. Okay, next, step number 4. Step 3 is the easiest one. Step 4, we're gonna find u1 and u2. Because your yp is in the form of u1 times y1 plus u2 times y2. And this is the major step. This is the major one. To find u1 and u2, we're gonna need the w1 and w2. Okay, let me start with the w1. So note that your y1, or from what I started with, my y1 is e to the 3x, and my y2 is e to the negative x, right? Make sure we use the same order as what we started. Yes, y1 e to the 3x and y2 is e to the negative x. So w1 is a determinant. W1 column 1, right? Column 1 gonna be 0 f of x, and then y2, the column for y2 remain the same as a w. And for w2, y1 prime, the first column, nothing changes. And then the second column gonna be 0 f of x. For the w1, 0, f of x is negative 3x e to the negative x, and y2 is e to the negative x, and its derivative is negative e to the negative x. And then use the determinant, and the 0 is a helper, right? So the cross down here, you get 0, and then subtracted by negative 3x e to the negative x multiplied by e to the negative x. They cross way up, cross way down, cross way up to get positive 3x e to the negative 2x. A lot of algebra going on, so just pay attention to every detail, okay? So W1, we got it. And W2, which is the Y1 e to the 3x, the Y1 prime, 3 e to the 3x, the second column, 0, negative 3x e to the negative x. Multiply cross way down, non-zero. We get negative 3x e to the 3x times e to the negative x. Simplify to be negative 3x times e to the 2x. Okay, they look alike, just negative sign, different places. Now, we're going to use W1 to find U1 prime. So U1 prime is W1 over W. See the notation, subscript 1, subscript 1. And our W from step number 2, W is negative 4 e to the 2x. Okay. W1 is 3x e to the negative 2x. W is negative 4 e to the 2x. Simplify before you do the antiderivative. So we have negative 3 over 4 times x e to the 2x e to the negative 2x on the top becomes e to the negative 4x. Okay. And next we're gonna find u1 from finding the antiderivative of negative 3 over 4 times x e to the negative 4x with respect to x. And we're gonna use bypass technique. I have negative 3 over 4. I'm gonna take care of that outside. So negative 3 over 4. And then inside here, from bypass, I can see if I use LEAD, just to make sure I set up the right u and dv. So the algebraic is x. The exponential is to the negative 4x. The upper one is my u. The lower one is my dv. So then I can use a tabular bypass. The left column find the derivative, the right column antiderivative. Starting with the u and the dv. Complete the table. Derivative 1, derivative 0. Antiderivative of the right column. I have e to the negative 4x divided by negative 4. Another antiderivative, oops, yeah, go away. So e to the negative 4x divided by negative 4 times negative 4 becomes 16. Okay. So many little things, you just have to be careful. And then multiply cross way down, cross way down. The first one, product positive, next one, product negative. So the first product, I would get negative 1 over 4 x e to the negative 4x. Okay, and the second one, negative sign, 1 times 1 over 16. So I put 1 over 16 e to the negative 4x. Do not add c because you are not done the entire process yet. For this one, you have to keep it as the like not worry, do not worry about the constant of integration. We're gonna need the core function or the basic function that come out. So right now we have u1 as negative 3 over 4 times negative 1 over 4 becomes 3 over 16 times x e to the negative 4x. And then minus and then plus sign, and 3 over 4 times 16, that's 64, e to the negative 4x. All right, next one. So we're going to find u2 by using u2 prime, which is from w2 over w. And what is the w2? I forgot. w2 is negative 3x e to the 2x. Where the w is, now I forgot again, negative 4 e to the 2x with the x. No x. Okay, make sure we get the right w to use. Yep, no x for the w. I okay. If we copy the wrong one, that means we're working on the wrong problem. Okay, negative gone, becomes 3 over 4 e to the, how nice, nothing, right? So going to be negative 3 over 4 times x for u2 prime. That gives you the u2 is the integral of 3 over 4 x dx, which is x squared over 2 becomes 3 over 8 x squared. Okay. We get both u1 and u2. Let's write down. U1 is 3 over 16 x e to the negative 4x plus 3 over x over 64 e to the negative 4x, where the u2 is 3 over 8x squared. And the last step number 5, put together as a particular solution. Yp is u1 times y1 plus u2 times y2. And recall the y1 is e to the 3x and y2 is e to the negative x. And then just put them as a product of u1 and y1, u2 and y2. u1 is kind of messy. Okay, so 3 over 16 times x e to the negative 4x plus 3 over 64 e to the negative 4x multiplied by y1, which is e to the 3x, plus the u2, 3 over 8 x squared multiplied by y2, or e to the negative x. Okay, the next step, just clean up e to the 3x multiply in, then we get 3 over 16 times x e to the negative x. And the second one becomes 3 over 64 e to the negative x. The last one is 3 over 8 x squared e to the negative x. Now we have 1, 2, 3, 3 terms, yp. Okay. To wrap up, so the general solution is y equals yc plus yp. Okay, yc, which is c1 times y1, c1 e to the 3x plus c2 e to the negative x, and then plus the 3 terms that we got from the yp, which is 3 over 16 times x e to the negative x plus 3 over 64 e to the negative x plus 3 over 8 times x squared e to the negative x. And you can leave it this way for this situation, or as you see, you have some light terms, e to the negative x, e to the negative x right here. C2 is just one form of the constant. 3 over 4 is another form of the constant. These two can be merged into like C2 star as a coefficient of the same variable term.